Welcome back to All This Math. This is Professor Parker. As you notice, I'm in a different location. I'm usually recording my videos from the crib down North Philly, but in a different location. I'm out in West Baltimore right now doing some content. So make sure you subscribe to the All This Math YouTube channel if you're not already. Make sure you drop a comment down below, especially if you have a question about anything I try to explain in this particular video. Please drop a comment or drop a question, right? If there's anything you're unclear about, right? I'll get the notification and I'll address it, in the comments, or even make another video, a subsequent video. All right. Make sure you like the video. Make sure you share the video with somebody else. All right. Now let's first read it. Like, we got a short word problem back here, as you can kind of tell. All right. Let's first read it. What does it say? It says Maurice. When I wrote this, I was thinking about Maurice Bishop. If you're not familiar with Maurice Bishop, definitely do your research on Maurice Bishop, a brother that was from Grenada, human rights activist, political leader, unfortunately assassinated by the United States government back in 1983 down in Grenada, in the Caribbean island. Grenada also has connection to Louise Little, who was Malcolm X's mom. You know what I'm saying? So definitely, do your research on Maurice Bishop, all right, in the island of Grenada. So Maurice walked 3/4 of a mile on Monday, all right? Then on Tuesday, he walked 1/8 of a mile. All right. Now, one thing I want to point out when we talk about fractions, don't say, or at least I suggest you say 3/4 instead of saying 3/4. Right? 3/4 doesn't really have as much mathematical value. 3/4 is giving you a quantity. It's telling you how much of something we have. What do we have? We have fourths. Our denominator tells us that we have fourths, and our numerator tells us how many fourths we got. We got three of them, 3/4. Here we got eighths. How many of them do we have, though? How many eighths do we have? Our numerator tells us we have one of them. So how many eighths we got? We got 1/8. All right. So 3/4 of a mile. Maurice Bishop walked on Monday. On Tuesday, he then walked 1/8 of a mile less than, right? He walked 1/8 of a mile less than, I keep saying that because it's very important, than on Monday. How far did he walk altogether? That's the main question. How far did he walk altogether? So altogether means we're dealing with a total. We're going to be dealing with how much he walked on Monday plus how much he walked on Tuesday. When you see the word altogether, that means you added something up, right? You added some different quantities up. That's what that word means. Make sure you understand that. Make sure you write that word down in your notebook or in your notes or whatever you're writing on, right? And identify the fact that it indicates you need to add some things together, right? You might even need to multiply some things together in some cases because multiplication is just repeated addition anyway. All right. So what are we adding together? How much you walked on Monday plus how much you walked on Tuesday. How much you walked on Monday plus how much you walked on Tuesday. Now, on Monday, don't touch the board, bro. On Monday, let's say MON. How much did he walk? 3/4 of a mile or 3/4 of a mile. So a mile is like 5,280 feet. Make sure you know that. He walked 3/4 of a mile. So he didn't walk a whole 5,280 feet. He walked a fraction of that. So we're going to write down 3/4, right? Now on Tuesday, how much did he walk? Did he walk 1/8 of a mile on Tuesday? No, he didn't. This is why we got to know how to read and be good readers, right? If you can't read, you can't do math. All right, straight like that. So the whole you know, I'm a reading person, I'm not a math person, or I'm a math person, I'm not a reading person. Let's throw that out the window because you can't be a math person if you're not also a reading person. And when you're reading, you're implementing a lot of mathematical approaches anyway, whether you recognize it or not, right? So we got to get rid of that false dichotomy between being a math person and a reading person. All right. But at any rate, he didn't walk 1/8 of a mile on Tuesday. He walked 1/8 of a mile less than on Monday. Now, how much did he walk on Monday? He walked 3/4 of a mile, 3/4 of a mile. So that means you got to figure something out. You got to figure out how much he walked on Tuesday. You got to do some math. So less than means subtract. But here's the key with less than. Pay very careful attention. Give me your undivided attention right now. Because less than don't mean do 1/8 minus 3/4. It means you take the amount he walked on Monday, right? And you subtract 1/8 from that. the amount he walked on Monday, subtract 1/8 from that. So that's going to be 3/4 minus 1/8. 3/4 minus 1/8. Now, you got to know how to subtract fractions, right? Now, it's a lot of skills built into this problem. You got to know reading comprehension. You got to know math vocabulary. You got to know how to add fractions, how to subtract fractions. You got to do a few things in order to understand a problem like this. All right. So 3/4 take away 1/8. Now we can't subtract these because our denominators are different. They're not common. We need common denominators. All right. Common denominators mean we got denominators that are the same number. This is a 4 and this is an 8. That's an issue, right? We need to switch this up. We need to create a fraction that's equivalent to 3/4 that has a denominator of 8. Why? Because then we would have common denominators, right? So 8 is already a denominator in 1/8. Now, check this out. What you need to ask yourself whenever you see a problem and you're doing subtraction of fractions and your denominators are different, you need to ask yourself, what's the smallest number that both of those denominators can multiply into? The smallest number. Now, it don't got to be the smallest number, but it's got to be a number that they both multiply into. But I'm going to tell you, if you don't pick the smallest number, if you pick a bigger number, that's just going to make the math more difficult. And why make the math more difficult unnecessarily? Why would you do that to yourself, right? Like some people will say, oh, just multiply the denominators together and get 4 times 8, which is 32. 32 could be your common denominator. It ain't the smallest common denominator. It ain't the LCD, what we call the least common denominator. It ain't that, right? It's a common denominator. It's a CD, but it ain't an LCD. I suggest you go for the LCD. In this case, the LCD is 8. 8 is the smallest number that both 4 can multiply into and 8 can multiply into. Because 4 times 2 is 8 and 8 times 1 is 8. I'm going to say it again. 4 times 2 equals 8. 8 times 1 equals 8. You see how they both multiply into 8? That's why 8 is the lowest common denominator, right? 32 is also a common denominator because 4 times 8 will give you 32 and 8 times 4 will give you 32. But why deal with 32 when you could just deal with 8? You want the smallest number because that's going to make the math more simpler. All right. So what we're going to do is we're going to rewrite this fraction with a denominator of 8. We're going to rewrite this fraction with a denominator of 8. But look, this one already got a denominator of 8. So it's nothing we need to change. We need to change this fraction, right? Because if this 4 turns into an 8, you can't just keep the 3. Why would the 3 stay the same if the 4 ain't stay the same? Like a lot of times when we do math, we got to really apply some common sense. You guys just think like, bro, if the 4 is going to change it to an 8, why would the 3 not change? Right? So dig this. Ask yourself, 4 times what number will make this an 8? 4 times 2, right? Now, whatever you do on the bottom is what you're going to do on top. So if I do 4 times 2 to get this 8, I'm going to do 3 times 2, and I'm going to get 6. And this is why we got to know multiplication facts. So we could do this real quickly. Now, we got 2 fractions that we can subtract, right? We can subtract one from the other because our denominators are the same. I got this many eighths, and I'm subtracting this many eighths. This many eighths minus this many eighths. What am I left with? What's my difference? I'm left with 5 eighths because I got 6 of something. I take away 1 of something. I'm left with 5 of them things. So 6 eighths minus 1 eighths is 5 eighths. So boom. So that means on Tuesday, how much did Maurice walk? 5 eighths. Right? 5 eighths of a mile. 5 eighths of a mile. Monday, he walked 3/4 of a mile. On Tuesday, he walked 5 eighths of a mile. How do I know? Because 5 eighths is 1/8 of a mile less than Monday, which was 3/4. 1/8 of a mile less than 3/4. 3/4 minus 1/8 is also 6 eighths minus 1/8, which is 5 eighths. All right. So now I know how much he walked on Monday. I know how much he walked on Tuesday. Now I can answer the final question. How far did he walk altogether? We talked about that in the beginning. Altogether means you add them up. Add up Monday's walking plus Tuesday's walking. All right. So now we're adding. So we're doing Monday, 3/4 plus Tuesday, 5 eighths. Now, once again, we don't have common denominators. If we want to divide, we don't need a common denominator. If we want to multiply, we don't need a common denominator. But if you ever want to add or subtract, you need a common denominator. If you want to add or subtract, you need a common denominator. All right. So now what's our common denominator? What's the smallest number that 4 and 8 multiply into? We already said it when we was doing subtraction. We had the same denominators. It's 8. It's still 8. Ain't nothing going to change about that. It's still going to be 8. The 8 still going to be the common. So I'm going to do this. I'm going to change this fraction, 3/4, into a fraction with an 8 for the denominator. Then over here, I'm going to keep this as 5/8. Now, why am I keeping this as 5/8? Because the denominator was already an 8. You don't got to change it if it already was an 8. If it's already an 8, you're going to keep it an 8. And if this was already an 8, this was already a 5, this still going to be a 5. Why would that change? Ask yourself. Make it make sense. Now, but this 4 is going to change into an 8, just like this 4 changed into an 8. So we're going to do 4 times 2, which is 8. Now, if I multiply by 2 on the bottom, that means I multiply by 2 up top. What's 3 times 2? 6. So now 3/4. And also, there's something else you should understand. 3/4 or 3/4 is the same thing as 6/8. 3/4 is the same value as 6/8. I know the numbers are different. I know that. But this is something you got to understand about fractions. You can have different numbers and have the same value. Think about a pizza, right? You got 2 large pizzas, right? One of the pizzas is cut into 8 slices, right? If you eat 6 of those, if you and your people eat 6 of those slices, that's the same thing as if that's the same amount of pizza as if the other large pizza was cut into 4 slices and you and your people ate 3 of those. They would be larger slices because it's only 4 slices. That means each slice is going to be bigger. But it's the same amount of pizza that gets eaten if you eat 3 of those larger slices, as if you ate 6 of those smaller slices when there was 8 of them. It's the same concept, all right? The same amount of pizza, even though it's a different number of slices. Think about it. Different number of slices, but it's the same amount of pizza. Different number of slices, but it's the same amount of pizza. Dig it? All right, so now 3/4 or 3/4 is equivalent to 6/8. So now we can add because we got the same denominators. We got common denominators. So this many eighths plus this many eighths. What's 6/8 plus 5/8? 11/8. All right, now that's what we call a improper fraction. That's more math language. 11/8. How many eighths altogether? We got 11 of them. We got to know our addition facts. You got to know that 6 plus 5 equals 11. I hope ain't nobody out there grabbing a calculator to do 6 plus 5. I sincerely hope that, right? 6 plus 5 is 11, so that's 11/8. So now you can leave an answer like this and say he walked 11/8 of a mile altogether, or you could convert this to a mixed number or a decimal, whatever. Let's convert it to a mixed number. How do we do that? Converting to a mixed number is like doing division. 11 divided by 8. How many 8s can fit into 11? How many 8s can fit into 11? How many groups of 8 can fit into 11? One whole group of 8 can fit into 11. Make sure you can see this on the camera. Now the camera's blocked off, so we're gonna go up here with it. So see, you just gotta improvise, right? If I write down here, you're not gonna be able to see what I'm writing. Now, one group of 8s can fit into 11, so that's our one. That's our whole number for the mixed number. A mixed number is called a mixed number because it's a mixture of 2 types of numbers. You're gonna have a whole number part and a fraction part. A whole number part and a fraction part. Make sure you understand why everything in math has the name that it has. Why do we even call it that? It's a mixed number because it's a mixture of 2 different types of numbers. You got a whole number part and a fraction part. Because one group of 8 can fit into 11, that's our whole number part, right? 2 groups of 8 can't fit into 11 because 2 times 8 is 16, and 16 is more than 11. So 2 groups can't fit, but one whole group can fit. But then you say, wait a minute, there's a difference between 11. What about the other 3 that's left over? Because if one group of 8 can fit, what about the other 3 that's left over? Because 11 minus 8 is 3, right? So that means that a fraction of another group of 8 can fit into 11. Also, a fraction, a part, a smaller part, not the whole 8, but a fraction of 8. So then we're going to have 3 in our numerator, and we keep 8 as our denominator. So this is how many 8s can fit into 11. One whole 8, right? And then 3/8 of another 8, right? So if you think about it, you break the 8 down into 8 equal parts. 3 of those parts can fit into 11. That's the extra 3. 3 of those parts can fit into the 11 also. That's the extra 3. You got one whole group of 8. That's this one right here. That's this one right here. One whole group of 8. And then what's left over? You got 3 left over, right? 3 left over because that's 3/8 of 8. You take 8, divide it into 8 equal parts, right? 3 of those parts can fit. 4 parts can't fit. 5 parts can't fit. 6 parts can't fit. 7 parts can't. Another whole 8 parts can't fit. That would be another group of 8 altogether, right? We can't do that. So the final answer is 1 3/8 of a mile. That's how much Maurice walked on Monday, and Tuesday. So you see the math we had to do? We have to understand fractions. We see fractions all the time. We deal with fractions when we go shopping. We deal with fractions in the store when things are on sale. We have discounts when things are marked up. Fractions is part of the language of math that we must understand, or else we're going to get taken advantage of. I'm going to just be quite honest with you. If you don't understand fractions, people are going to take advantage of you and steal your money. Straight like that. They're going to steal your money. So if you like getting your money stole, don't learn fractions. But if you want to be able to defend yourself against that, learn fractions. Make sure you know them frontwards and backwards. If you're a parent, make sure you learn them. It's never too late to learn them. And then teach your children so you can protect your children from being taken advantage of. All right? So make sure you subscribe to the All This Math YouTube channel. Make sure you drop a comment down below. If it's something you didn't understand and you go back and rewind the video, you still don't understand it, drop a comment down below. All right? I'll answer your question, or I might just make a follow-up video. All right? Make sure you like the video and share the video with somebody else. Don't be selfish. All right? I'm going to see you on the next video. Peace.